So in the previous video, we have seen the basic definition of BOD, and also we have seen how to calculate the BOD in the lab method. Okay, so we have seen the formula of BOD 5. So what is the 5 day, or what is the 5 signifies? It signifies the amount of oxygen consumed in 5 days, and that is the carbonaceous oxygen demand. Now, before going to the next calculation, a small part is given that we have to understand. So we'll name this as BOD mechanism, or what happens exactly during the formation of the BOD. So just pay attention to what I am saying right now. See, there is some organic content which is present in wastewater. Okay. Now, when the organic matter, it consumes the oxygen, that is, it reacts with the oxygen, there is some oxidation reaction that takes place, and this organic matter gets oxidized. So that means as soon as the days passes, the organic content in the sewage, it decreases. How it decreases? It decreases by consuming the oxygen, that is by oxidizing itself. So you can say that particular period of time, the amount of organic matter, it decreases. So if we try to draw it mathematically, we'll keep one. Okay, we'll keep this amount of organic content here on y-axis, and we'll keep the time in days on x-axis. Okay, so we have seen right now only that as soon as the time passes, what happens? The BOD, or the organic content, it decreases. So during the start, let's say the initial organic content, we are denoting it with L0. So this is the initial organic content. So initial organic content, and after, say, let's say after T days, so after certain time, you can see the organic content has been decreased, and what is the new value now? The new value is LT. So LT stands for organic matter or organic content after T days. Now, so this we have seen with respect to organic content. Okay, so the organic content with respect to time, it is decreasing. So how it is decreasing? It is consuming the oxygen. That means the amount of oxygen requirement is increasing as the organic content is decreasing. So if we try to plot a graph, so this we have already seen this graph. So if you plot a graph of BOD and time, so if you plot a graph with BOD and time, we can see that the oxygen demand with respect to time is increasing. Okay, so initially it is 0 and then it is slowly increasing. So after 5 days, so let's say the ultimate level of the BOD, it is called as Y5, or this is called as ultimate BOD, that is the maximum BOD. And after time T, so the value is this one, that is YT. So taking the equations here, we have the following equations. So first equation is LT is equal to L0 into e to the power minus KT. Then YT is equal to L0 minus LT. So that we can write it as YT is equal to L0 into 1 minus e to the power minus K into T. So these formulas are derived by using the kinetics. So we don't need to go into detail of the derivation. You just remember the formulas here. So 5-day BOD 5-day BOD at 20 degrees Celsius. So this is Y5 at 20 degrees Celsius. This is equal to, we have seen the formula first, DO initial minus DO final into dilution factor, and the second formula is L0 into 1 minus e to the power minus k into t. Here is 5. Okay, so instead of kt, k into 5, where this k is called as, where k is called as BOD rate constant. BOD rate constant. So this yt at t degree Celsius is equal to L0 into 1 minus e to the power minus kt into t. Minus k into t. And this kt formula, kt is equal to k20 into 1.047 whole to the power t minus 20. Now this k value here it is called, or here it is taken with base 10. Okay, so if base 10 is there, then we have to use this. If kt formula with base e it is asked, so when we will solve the problem you will understand it better. So it will be kt with base 10, multiplied by 2.3. So these are the various formulas that we will be using for calculating the BOD or BOD calculations. See, the initial formula we have seen, that is DO initial minus DO final. Now this formula, this is derived by using the reaction kinetics of the BOD. Okay. Now we'll see the numericals from the next video.